Hello everyone and welcome back to my channel Gyan Sampada. We have already discussed many methodologies to deposit a thin film on a substrate, and today we are going to study about another type of technique which is called as spin coating. So this is another type of technique which is used to deposit a thin film over a substrate according to the applications. And this method has become a leading choice of most of the research centers in numerous domains because it gives relatively good results and the methodology is also simple and the equipment is also inexpensive. And today we are going to see about the details of spin coating technique, where we will study about the working principle, the instrumentation, that is the type of instrument which is used and its working, the formula used to calculate the thickness of the thin film, different parameters which decide the quality of the thin film, what are the uses, advantages as well as disadvantages. So in detail we will briefly discuss about spin coating method today. So let's learn some details about spin coating. According to the name, spin means some rotations are given. Coating, the precursor material is coated over the substrate. How it is done? Let us see. So first we will study about the working principle or the introduction part. And spin coating is a procedure which is used to deposit uniform thin films onto a flat substrate. And how it works? So whichever coating material is there, small amount of coating material is applied onto the center of the substrate, and the substrate can be either spinning at low speed or not spinning at all. So this is when the precursor material is put at the center of the substrate. And once it is put, the substrate is then rotated at a high speed in order to spread the coating material. And it is clear that as the rotations are given, coating is taking place means the principle behind it is the centrifugal force itself. That is, the coating material is spread by the virtue of centrifugal force. So clearly, centrifugal force acts as a working principle behind spin coating methodology, and the machine or the instrument which is used for deposition of thin film is called as a spin coater, or generally it is called as spinner. So here we can see that the precursor material is put over the substrate and the substrate is rotated, and due to centrifugal force the solution will spread over the substrate and a good quality thin film is formed after evaporation of the solvent material. So now let us understand the procedure by knowing the stages which are very important in spin coating system. So the first one is fluid dispense, second is spin up, third is spin off, and fourth is evaporation. So these are the four steps by which we can deposit a thin film using a spinner. Fluid dispense means the precursor material or the target material is put over the substrate. Spin up means due to the rotation, the precursor material will be spread out over the substrate, and spin off is removal of the excess of the liquid from the substrate due to the high angular velocity, and finally evaporation to get a uniform thin film. So this is in brief. Now let us understand the method by knowing the instrumentation, that is how the instrument works. So typically this is one type of a spinner where you can observe a substrate holder and a set of functions which need to be programmed to get the required thin film. So first, the substrate is placed on the sample holder, that which you can see here, and this sample holder holds the substrate by virtue of vacuum, which is generated by a dedicated vacuum pump, so that while spinning the substrate remains adhered. Then the substrate holder, if we want to understand, then it contains different rings which are having some grooves depending on the size of the substrate. Means whichever size of the substrate we need to get the thin film, according to that we can set the different rings with the grooves. So smallest one can deposit small wafers, then the medium of approximately 3 inches we can say, or the larger ring of approximately 4 inches, which depends on how much size of substrate we need to spin coat on. So clearly we can understand that based on the size of the ring we can deposit different size of thin films. So after that we need to set the program, that is to set the speeds in terms of RPM. And generally there are two types of speeds here. So one speed is to spread the solvent along with the precursors, which comes under the stage of spin up. And the second speed what we are going to set up, that is the acceleration while programming, is to dry off the solvent and to thin down the deposited film, based on which uniform spreading takes place on the surface. So the setting of acceleration is especially to give a higher speed step to ensure that the solvent can be evaporated. So it can be set up like 1000 rpm for 60 seconds, or the acceleration of 400 units, or the acceleration of 500 units, like that. So one thing we need to remember, generally the spin coaters are almost of similar functioning, but only some of the interface, that is the software interfaces, can be differing. The principle, the working, everything remains the same. And many a times in the setup one extra setting will be there, like ramp down step. So that setup ensures the spin coater, it doesn't stop abruptly. So whenever the deposition of thin film is taking place, we have applied certain speed and acceleration to the coater, and suddenly if it stops abruptly, it is going to harm the quality of the thin film. So this ramp down step, which is another setting in some of the spin coaters, ensures that spin coater will stop very gradually and not suddenly. So these are some of the programming which will be with respect to different softwares corresponding to different instruments. And now we can understand what actually happens. So some drops of solution or precursor solution is dispensed over the substrate, and sometimes this precursor solution is called as ink. And we need to know that the substrate should be hydrophilic, which then rotates to high angular velocities of 100 to thousands of rpm to spin off aqueous solution, which results in thin as well as uniform films. And during spinning, solvent contained in the ink will start to evaporate, which then facilitates the formation of solid like gel film of the target materials, because as evaporation takes place, means solvent material will be coming out of the target material, due to which the viscosity of the target material is going to increase. So liquid form of precursor will be slowly converted into gel like solid form of film. So this is how a spin coater works. So after instrumentation, let us understand about some of the important formulae, which is very important to understand the thickness of the film. So the thickness of resultant gel like film is mainly determined by the precursor viscosity as well as the angular speed. So here precursor viscosity is denoted as eta and angular speed is omega. And this is the formula for thickness of resulting film, that is H is equals to 1 minus rho a by rho a naught into 3 eta m divided by 2 rho a naught omega square raised to 1 by 3, where rho a is the density of the volatile liquid and m is the rate of evaporation, eta is the viscosity and omega is the angular speed. And by calculating evaporation rate, that is through some experiments, we can simplify this above equation, and it is said that the equation reduces to H is equals to A into omega raised to minus B. Here B is a constant which generally lies between 0.4 to 0.7, and that is observed experimentally. So here we can observe that H is depending on viscosity of the precursor liquid as well as omega, that is the angular speed. So clearly we can say that if we want to obtain a good quality thin film, then higher angular speed is necessary. That is, omega should be high in order to get lesser thickness of the film, because these are inversely proportional to each other. So higher the angular speed of the substrate, thinner will be the film which is coated over the substrate. And this is the methodology which we can easily observe or just visualize. So once the liquid is put over the substrate holder or the substrate, it will just spread off due to the effect of centrifugal force, and we get a uniform thin film. And as I told, there are different types of spin coaters, but the difference is only with respect to software interface. And clearly here we can observe some programming can be done here over the display. It will be seen, and the substrate holder is covered with a vacuum chamber so that it assures a good quality thin film, and also the substrate will be hold on properly. So here these are some of the different types of spin coaters. Then next, let us move on to the main parameters which are going to decide the thickness as well as the quality of the thin film. So already you might have got the idea what are the parameters. So let's see what all things are going to affect the quality of thin film. So first thing is the property of the solution. That is, the solvent whichever is used should be usually volatile so that it will get simultaneously evaporated. So this volatility is going to influence the crystallinity of the coated film. So property of the solution is the first parameter which decides the quality of the thin film. The next is the substrate properties. Any or whichever substrate we require, we are not going to use it. So first thing is the substrate should be flat enough to get a uniform quality of thin film, and the second thing is it should be hydrophilic substrate, means it should be liquid loving substrate, because if it doesn't hold on the liquid precursor, then gel like cannot be formed and we finally won't get a thin film. So hydrophilic substrate is recommended. And the third parameter is the acceleration and the spin speed. So we have understood where the spin speed and acceleration is related. So generally spin speed relates to the spin-off process, whereas acceleration is to ensure that solvent gets evaporated. And higher angular velocities is mandatory in spin-off process. That is where the excess of precursor liquid will be expelled out from the surface of the substrate. The fourth important parameter is the annealing temperature. So at what different temperature evaporation of the solvent is done is also going to decide the quality of the thin film. So annealing generally makes the thin film tougher, that is we can say more stable. Whichever the particles will be adsorbed over the substrate will be stabilized by this annealing process. So it is clear that a number of parameters are going to decide the quality of the thin film. Even if the working principle is very simple, however, to get a uniform thin film with a good quality, all these parameters are to be taken care of. And finally, we can say that the viscous force and the surface tension are the main causes for the flat deposition on the surface. And these are the main properties of your liquid, that is ink, which we are going to use to coat the substrate. And after these parameters, let us know about the uses. So any type of a thin film can be coated over the substrate using this spin coating technique, and the spin coating method is widely used in microfabrication of functional oxide layers on glass or single crystal substrate using generally sol gel precursors, where it can be used to create a uniform thin films especially with nanoscale thickness, that is of the range of 10 raised to minus 9 meters. So different materials, it may be a perovskite material which can be used for the solar cell fabrication. There also spin coating process can be utilized, and also it is intensively used in photolithography to deposit layers of photoresist of generally about 1 micrometer thickness. So in this manner, a number of uses of spin coating method are there. Even it can be used for coating the substrate using some polymers or any type of material. Then moving to the last part, that is advantages and disadvantages. Firstly, the advantages, as we have seen already, the spin coater is relatively inexpensive technique, because as such if we look at, the spinning plate is very much cheaper when compared to the vacuum deposition systems, because we have studied already about chemical vapor deposition or thermal evaporation methods, MOCVD. All these things require highly sophisticated vacuum chamber, or there are some requirements as such. But here in spin coating, a small vacuum chamber is enough so that adherence of the substrate will be there, and other things are comparatively very cheap. And then the second advantage is it is a quick and easy deposition process which can be performed by any person. The third point is the good reproducibility and the easy integration with conventional lithography based fabrication techniques. Good reproducibility and easy integration means the process can be repeated multiple times, that also very easily. So here clearly we can observe there is a substrate holder over which substrate is kept. Using a pipette or something like that, precursor solution is put over the substrate. Then the spin up, where due to centrifugal force the precursor liquid will be spread over the surface, and due to higher angular velocity extra liquid will be spinned off and evaporation of solvent particles will be there. So finally we get a uniform thin film which is generally of good quality and is easily obtained. So we need not wait for the second deposition process after the first. So one after the other coating can be done. So these are some of the advantages of spin coating method, and now let us move on to the disadvantages. So some of the main disadvantages is that it is having difficulty in creating multi-layer structures generally which are greater than 2 layers. So monolayers can be easily formed, but more than 2 layers it is difficult, because when we are just going to create multi-layers, due to the high angular velocity the first layer also gets affected while formation of the second layer. So this is the main difficulty. Then there is also a possibility of presence of contaminants like some traces of the solvent or humidity, oxygen, etc. Then third one is difficulty of accurately controlling the deposition. So homogeneity, rugosity, etc. cannot be controlled accurately. However, satisfactory deposition will be there, but accuracy when compared to other sophisticated methodologies won't be observed in case of a spin coated thin film. Then if we need to create or deposit extremely thin film, then it is highly impossible, especially when the film thickness goes below certain nanometers, that is less than 10 nanometers. So such monolayers or films cannot be produced using spin coating. Then when we just went through the instrumentation, you might have got the idea about the limited scalability. So if we want to deposit more amount of the precursor material over large area, then it is having its own problem, because substrate holder itself will be small, then over which substrate has to be kept, and on that film will be deposited. So we can't use a large area, that is these are not compatible for manufacturing large area thin film transistor arrays and all. And finally we can also see that most of the precursor liquid, that is the ink, will be wasted during spin-off process. And it is said that almost 95% of the ink will be wasted off. So due to higher angular velocity, the extra solvent or the precursor solution whichever will be there over the substrate will be expelled out from the substrate. Generally 95% of the liquid will be expelled out and only 5% of the liquid is generally utilized for formation of the thin film. So here we can say that there is a loss of precursor material. As such, if the precursors are cheaper, then it doesn't affect. But if the precursors are costlier, then spin coating methodology is going to be a wrong choice for deposition process. However, if we compare with wafer phase deposition technique, then there is a less loss of material, but with respect to liquid phase deposition, loss of precursor material is more. So these are some of the details which I wanted to share with you all, where we started from what actually is spin coating, how is the process taking place, what is the principle behind it, what is the instrumentation, that is how the instrument is going to work, then the general formula to calculate the thickness of the material and different parameters over which the quality of the thin film depends, and finally pros and cons of spin coating. And these are the main details which we need to know when we are dealing with spin coater, and I hope I have cleared at least some of the details regarding your queries. And one important thing we need to always remember whenever we are depositing a thin film, it may be a few nanometers or a few micrometers, a small change in the process or in any parameter is going to affect the final results, because here we are dealing with the low dimensional structures, or we can say nano size structures, and as the size of the particles is going on decreasing, the properties will vary very appreciably. So many a times the same precursor methodology which we use, the same instrument or the same procedure we follow, finally the results are going to be different, because even a smallest of the thing is going to affect, like the order of adding the chemicals while preparing the precursor solution, it is also a factor. Then the temperature, the surroundings, whether you are going to use a vacuum chamber or no, the type of the substrate, the nature of the substrate, the quality of the substrate, as well as the chemicals which are used in the precursor material. Each and every factor is going to be responsible for the property of the thin film which you deposit. It is not just with spin coating methodology but with any of it. So we can say that this itself is the beauty of the size. As the size goes on decreasing, when you go from bulk material to low dimensional structures, or from multi-layers to a bi-layer or monolayer, how the properties are going to change, each and everything is itself magical. So whenever we are dealing with a thin film or of any such kind, then each and every parameter has to be tuned and the properties have to be studied. So this is it for today's class, which I think was helpful for you, and see you in our next class. Till then, study well, stay tuned, and thank you for watching.